This is step bar having two elements. First element is made by the E1 and second element is made by the E2 material. Okay, so the material property is different. There are different area of cross sections A1 and A2. Length of the first element A1, L1 and L2. Okay, so these are the there are two elements. Element number 1 in between node 1 and node number 2. Element number 2 in between 1, 2 and 3. Okay? Node number 1 is fixed support and at the free end there is a load of 10 kilonewton. We are finding the nodal displacement, stress developed in each element and reaction force at the supports. So this is the given information. Okay, we start APDL mechanical. Go to the APDL mechanical. First step, file, clear, start new. Do not read the files. Okay. Yes. Second option, change job name. Give the job name. What is name? Step bar. Step bimetallic bar. Okay. So that is the name of the experiment. Do you want to create log file or error file? Yes, I want to create log file and error files. Okay. Now third step, go to the change directory. Select your working directory. Okay. So in the we select your folder as a directory. We select any one of the folder. Main menu. Okay, black color option, preferences. It is a what kind of analysis is this? It is structure analysis. Okay. Okay, go to the next option. Preprocessor, element types, add, edit, delete, add, and we select beam. Beam and 2 node and 188 as a element type. Okay. There are two elements. Okay. There are two elements having different properties. First element having different material, different cross-sectional area, and length of the element is also different. Second element having also made of a different material. So we add two elements. Okay. Instead of using one element, we add two elements. Now we add another element. Okay. Go to the add again, and then we select beam 2 node 188. Beam 2 node 188. So this is the element type for second element, second material. Okay. So we select these two, type 1 and type 2. Type 1 for first element, type 2 for second element, because they are different properties. Metal property is also different, area of cross section is also different. That's why we select two types of element. Okay. Close it. We check real constants, add, edit, delete. For beam we select add rate. Now go to the third property. There is no real constant set for the beam element. We go to the metal props, metal models, structural, linear, elastic, isotropic. We convert this 200 GPa to so it is like using converter. We find the metal property of. So these are the property 2 into 10 raised to 5 and 0.25 is a Poisson's ratio. Okay. So this is the linear properties, linear elastic property of first material. Okay. Now we proceed for second material. We go to the material. The material है ना? There is the option material. Go to the new model. Go to the new model. Menu bar मध्ये बघा इथे menu bar box च्या menu bar मध्ये material new model. So go to the material new model. It is material ID number 2. Material ID number 2. Okay. Now it asks for the there is number 2. We also go to the again structural, linear, elastic, isotropic, and Poisson's ratio is what is the property? 150 GP E5, 1.5 10 raised to 5, and it is also we write 0.3. 0.3 is the total property. It is not. It is a Poisson's ratio, and it is the modulus of elasticity. Okay. 0.3. So in the block, झालं रे झालं. हे रो. झालं. Color option section. Okay, in the section there is a beam. Okay, we select common section. Okay, in the common section, the beam there are two. So this is the first ID. What is the ID? ID number 1. It is for first material, and name of the material is what is name of the material? It is A1. Okay, A1 code. It is area of cross section of first tile. And then we select a subtype. First is option is square. It is square. Okay, first option. Subtype मध्ये बघा square is like solid square. Now we put the value of B and H. B for breadth, H for height. What is the breadth? It is 14.14. H, it is a square. That's why it is same. 14.14. Okay. So area of the cross section is given. That is 200 mm square. And for with the help of area square, length side square, we have to do square. Side L is equal to 14.14. So that is the simple calculations. Apply, preview, apply and preview. This is the cross section of the given beam. It is the first preview. Click on the mesh preview. After meshing, we get this option. Okay, mesh preview. After meshing, you observe this area of cross section 200 mm square. Moment about y-axis, moment about y-other axis, and lot of calculations are done by automatically. Okay, for this cross section. Now click OK. Okay, now click OK. Now we take a photo of this. Go to the plot control, hard copy to file, JPEG format, and you give the name OK. Okay. Now we require second cross section of the beam for second element. So we go proceed for beam common section. Again we change the ID number 2. Okay, give the name A2. Give the name A2. Okay. Common section. Same blocks. Click on the common section. Then A2. Then subtype is square, solid square. And what is the area? Area is 100 mm square. So what is side? Under root of 100. 10 point. It is 10. The side of B is a 10 and H is also 10. Now we will proceed for apply. Okay. Apply and preview. Area of cross section is 100 mm. Moment about y-axis, moment of y-axis, moment of z-axis. So we take photo of this calculation. Go to the plot control, hard copy to the file in the JPEG format. Okay. Now we proceed for modeling. Go to the modeling, create. Now go to the modeling. We create nodes on inactive CS. We select node number 1. We select node number 1. Node number 1 at the origin. We assume that node number 1 at the origin. We select x coordinate 0, y coordinate is 0. X, y coordinate. Okay? And then place apply. Okay? For second node, we will place node number 1. Node number 1 replaced by 2. And the distance is how much? 200. X coordinate is 200, y is 0. Apply. Node number 3. Node number 3 at a distance of 300 mm square from the origin. So x is 300 mm and y 0. Okay. So we get 3 nodes on a screen. So node number 1 at the origin, node number 2 at the this location, and node number 3. Next option in beam that is elements. Okay, element attributes. We select beam. There are two beams. Okay, there are drop down list. So for we create first beam, so beam 1. There are two cross section materials, material 1 and material 2. So we select material 1. Okay. Now we select cross sectional area, section, sectional number. It is A1 for first element and it is in a straight form. Okay. Okay. These are the material attributes for first element only. Okay. Now go to the auto numbers. Auto numbers. Auto numbers through nodes. We create first element only. फक्त पहिला element create करायचा आपल्याला. Node number 1 and node number 2 we have to select on the screen. ठीक है? And okay. In beam number 2 for second element, and there is a material model number 2. We select second material model, and section is also we select 2. ठीक है? All three properties should be second type and it is in a straight form. Now we proceed for OK. Okay, for this is the second attributes of the second element. Now we create elements, auto numbers. Go to the auto numbers, through nodes. Through nodes we want to create second elements, that's why we select node number 2 and node number 3 only and say OK. This is a second element. The color is different because the property of this element is different. Now we proceed for meshing. There is no meshing because we have to create element. Now we proceed toward the boundary conditions. We apply boundary conditions. Go to the loads. Blue color, black color option, loads, and define loads. Apply structural displacement on node. ठीक है? Node number 1 is fixed support. Number 1 is having fixed support, that's why it is a fix. We apply boundary condition at node number 1 only. Okay? So we select node number 1. Okay. We fix all DOF, all degree of freedom. The value of displacement is 0 because it is fixed support. Okay. So we get this triangle. So due to fixed support, the node number 1 is now it is fixed. Now we apply to the force and moments. There is option structural. Okay, apply structural define loads. Apply structural force or moments. Now we apply force and moments on node. In the figure we observe that there is a force acting at node number 3. That is a free node. Okay. So what is the value? The force of 10 kN is acting in x direction, positive x direction. It is a positive x direction. The force acting at freedom it is 10,000 Newton. Okay. Now we proceed for next. What is next? We go to the solution. We create a model. Okay. Go to the solution. Solve. Current LS. Okay. Solution is done. Within fraction of second we get solution. Close this box. Now we observe the results in the general post processor. Now we proceed for plot control, animate, deform results. Okay, DOF solution. In this direction, it is deformation is possible. X direction. So translation UX we selected. Okay. This is the deformation of animation of beam. This forward direction only and this forward and backward directions. So you can control the speed of animation by using this drag button. Okay. Now we scroll the middle button slightly. Stop killer, stop कर दो उसको. We get this and we take photo of this plot control, hard copy to file JPG format. Okay. It is stored in your working directory. Click here isometric view. There is right side menu bar is there. There is a isometric view. Okay. Now go to the plot control, style, size and shape. size and shape. ठीक है, there is option, second option display of element on करना है इसको. ठीक है, okay. Now these are the elements. The first element different cross sections, second element different cross sections. We go again, plot control, animate, deform results, and UF solution UX. ठीक है, so it is completely red. ठीक है, red means the deformation is not, it is a fail component because the load applying on this, इसको जो force apply किया है, it is very high high force, and due to this it become red, completely red. It try, it going to fail. Go to the stresses, plot control, animate, deform results, stress, and the one minus stresses. This is 3D equivalent stress. Okay. So there is no effect on the body. The load applied. So now we go to the preprocessor. ठीक है. Define loads. Loads में ये लोगों. We go to the loads. Define loads. Apply. Apply ला minimize करायचे. Minimize, apply, and then there is bottom options. क्या है? Delete. We want to delete the load. Go to the structural, force moments, on node. We select node number. Node force to apply where it is applied. It is applied at node number 3. So we select node number 3. Okay. Then we delete all forces acting at node number 3. Okay. We select node number 3 and apply force of 3000 Newton. We change the force now. Okay. ठीक है. This is force acting at node number 3. Instead of using 10,000 Newton, we apply here 3000 Newton force because 10,000 force is very, very large. Now we proceed for solution. Now solve again. Solve. Current LS. Okay. Solution is done. ठीक है. General post processor. Go to the general post processor. Plot control. Animate. Deform results. UX solution UX. So in this animation, DMX value is 0.35 mm for the load of 3000 Newton. Okay, and this MX at the free end, there is MX, means that is the maximum deformation is possible at node number 3. Close the animation. Go to the finder stress. Go to the plot control, animate, deform results, stress, and go to the DOF. So 1 minus stresses. 1 minus stresses. Okay, okay. Now stress will be happy here. No stress data is available. Okay. Hard copy to file. Hard copy to file. JPG format. Okay.